Hey everybody, it's Mrs. Slauson. So we are in your note packet and we are on page 11. And after that longer video, we're going to actually look at how you do this process called completing the square. And we're going to be doing this with our notes and not with those algebra tiles. All right, so what we're doing is, in our last couple chapters, chapter 7 and chapter 8, we looked at these things. So let me turn on a light here. What we looked at is if you are given factored form. This was chapter 7. This was Showcase of Learning 3. You learn to get it into standard form by distributing. So my students know this as the neighbors meet the neighbors. So if you're not one of my students, then that will sound a little weird to you. But distributing, it's just a bunch of multiplying. So you can write distributing here. You can write multiplying because that is distributing. Or my students, we wrote the neighbors. And I'll explain what that means in just a moment. So we're not going to do both of these problems. We're just going to do one. So what I explain to my students when I talk about the neighbors meeting the neighbors is that, you got x plus 3 living together and x minus 4 living together, and they're right next to each other. So these people better like these people. So what happens is x goes over to meet the neighbors first. And so what we talked about is that x never needs to meet 3 because x knows 3. So when x meets x and these little loops are distributing loops, you get x squared. And then when x meets this negative 4, we get negative 4x. And now that x has met everybody, now it's 3's turn to go over. And so 3 will meet x and negative 4 as well. And so when we start a new neighboring loop, we start a new row. So 3 and x make 3x, and what I do is I stack it under the term that it's alike with. And then when 3 multiplies and meets negative 4, we get a negative 12. And then what we do is we just add like we did in elementary school. This would drop down. When I add negative 4x and 3x, I get a negative 1x. And then this negative 12 doesn't have anything to combine with, add up with, subtract with, whatever you want to call it. And it just drops down. So that's why we call that the neighbors meet the neighbors. So again, you went from factored form to standard form by doing this. And then in our last chapter, chapter 8, you went from standard form to factored form. So we followed this little route. And we did it by factoring. And so just a reminder of the rules of factoring, that you always start with your GCF. And then depending on if there's 2 terms, you would do difference of squares. And if there's 3 terms, you did the x. So these problems, there's not a GCF, but we would have made our x here. So in the previous video, we did a good amount of factoring, so I'm not going to do any factoring here. Instead, what we're going to do is, before we jump in there, let's just review our 3 forms real quick. Standard form tells you the y-intercept. So just by looking at this problem, all y-intercepts have an x of 0. And if I put 0 in for this term and this term, these terms turn into 0, and you'd have 0 and 0. So a quick look, you should just know that your y-intercept is going to be that 10. Vertex form. Vertex form tells you the vertex. And back, again, looking at our notes from page 9, it would tell me to do the opposite of h. So that would be, I see negative 3, so I want 3. And then it said just k. And k is the number that's added or subtracted at the end. So I want to see this as a negative 7. And that one I don't do the opposite. I only do the opposite of what's in the parentheses. And then factored form tells you the x-intercepts. So in those notes, what we wrote down is that it's just the opposite of p and the opposite of q. But that only works if it's x minus or x plus a number. So this trick of doing the opposite will work for this one. I know that this one is going to have an x-intercept of 2 because I see negative 2, 0. In x-intercepts, y is always 0. This trick doesn't always work. Tricks work a lot of times, but sometimes it doesn't work. So when we're doing this opposite, what we're really doing is finding out what will make these parentheses, so x minus 2, actually be worth 0. And then you would just solve for x, because this is a solving problem. I do that by adding 2 over, and I get 2, and that's what really makes it the x-intercept. So if I put 2 in here and do the math, 2 take away 2 is 0. And if I put 2 in here, it doesn't even matter what I get because I'll have 0 times whatever this number is. And as soon as you multiply by 0, your answer is going to get 0. So by putting 2 in here and doing all this math, I'll get y to be 0. So here I can't do that trick. I can't just make this -3, because if I put negative and 3 in here, I need to get 0 out of these parentheses, and I wouldn't do that. So sometimes you can't do the trick. So to find this one's x-intercept, I'll actually have to set these parentheses equal to 0. And then from there, to solve for x, I'd subtract 3. And then I would move the 2 over by dividing, and I get a nice decimal number. So actually -1.5, if you put it in here, makes this 0. And then if you put -1.5 in here, you get something else. But 0 times these parentheses will make that y become 0. So if x is -1.5, that will make the y 0. So that's just like a little interlude. That'll come up later, but just to give you a heads up on it. All right, so we're going to be skipping page 12 for now and just jumping to page 13. And now, without the use of my algebra tiles, okay, I am going to be showing you how do you go from standard form. Remember, if I'm going too fast, just pause the video, to vertex form. And this process is known as completing the square. Okay? So the first problem, so we're going to start out tough from the get-go. The first issue that we're going to run into is that when I showed you those algebra tiles, I only showed you an x squared, and here we have a 3x squared. So that's something I want to keep in mind. The other thing I want to show you is that, you know, when we worked with those tiles, so I'm going to switch screens here, and I hope this works. You know, we had our, let me put my labels on, we had our x squared, and then we would have had these tiles here, right? And we kind of built this rectangle, all right? So I'm going to be coming back to this in a second. But we also had those single tiles, and we always kept those single tiles off to the side. So what I did is I kind of put all the x squareds, or all the x's together, and then just the numbers off to the side. So look, I found this great interactive website and used it after I made the video. But anyway, going back to this, so I got to get back to the correct screen that I want to be on. What I'm going to do is the same thing. I'm going to put these x's together, and I'm going to separate them from the non-x. And as I do this, I'm going to do something called completing the square. So since I call it completing the square, we're going to be finding a number to put here. And then here's the other one, those yellow squares just to the side. And what I want to do is make something that's equivalent to this. So if I add something, so for instance, you're sitting watching this video, if you walk into my classroom and I give you $3, I'm going to get in a lot of trouble. So you can't walk out with more than you started. So if I'm going to give you $3 here, before you leave, I'm going to have to take those $3 back, unfortunately, to keep what you have in your pocket the same amount. So I'm going to add a square, and then outside of the parentheses, I'm going to subtract a square. Because if I add a number and then just take it away, this is still worth 3x squared plus 12x plus 4. I haven't changed it. It's still equivalent. Okay? So, like I said before, I never worked with anything that had 3 of these. We only worked with 1. So what we're going to have to do is change this problem that we're working with so there's just an x squared. So that's the step. You're going to form your parentheses, and we're going to divide out the leading coefficient. I need to have this as x squared. So whatever this leading coefficient, I'm going to, when we say divide out, think of it as the GCF out. So I'm going to divide that 3 out. Now GCF would imply that we're taking the x's as well. We're just taking the leading coefficient. So that's why divide out might be a better word. And 3 and x squared make that 3x squared. And then I need 3 and a number to still make that 12x. So that would be a 4x. So this is still 3x squared. This is still 12x. I'm just going to copy the rest. Okay. And now what we're going to do is I'm going to jump back to the screen. I would normally have x squared plus 4x. And so the very first thing I showed you with those algebra tiles is if I have x squared plus 4x, we would have taken those 4 x's, right? So, and my goal is to take this shape that's in blue and green and make a square out of it. So I would have taken these and separated them. So I basically cut them in half, and then those don't work that direction. I'm going to swap them out for these, and I would put them here. Okay? So let me show you visually what I'm doing now, kind of tying this into what we did. So I'm going to take this 4. I cut it in half, so I had 2 in each group. And then what I need to do is figure out, well, how many little squares need to go here? And I would need to fit 4 in here. And hopefully I can see that without doing it, because this is a 1 and 1. So this is a 2 here, and then 2 more here. And then to fill in this area, I would just take the 2 here times the 2 here to get that 4. I hope that makes sense. And so instead of writing 2 times 2, a number times itself, what I'm going to do is just write that as 2 squared. So, and if you want a calculator, don't do 2 squared, do 2 times 2. Not because it's 2 times 2, but this 2 says to multiply this 2 times, and I get 4. So that's how many little squares I need to put there to have a perfect square. Okay? I hope that makes sense. So from there, what I need to do is if I added amount here, I have to take an amount here. So it looks like I just gave you $4, but that's what it looks like. Actually, what I did is I had some ones folded up, and there were actually some extra dollars in here. I didn't really give you $4. What I actually gave you was $12. And so I'm going to have to take those $12 back. So you're probably thinking, no, you didn't. You only gave me $4. So this is where the $12 are, because that 3 affects everything in the parentheses. Because remember, that 3 was really 3x squared, and that 4x was really 12x. So this 3, that 4 might look like a 4, but it's actually worth 12. So since I gave you 12, I'm going to have to take the 12 away. And now what we're going to do is we're going to make this vertex form. So when we're done, it's going to look like similar to this, little different. Okay. So the first thing I want you to realize is that your A is just this 3. All right. And then if we did take the time to factor it, like in the warm-up that you watched in the video before this one, you would have a square. So what would happen, I'm going to flip back to the screen, is I have a perfect square here, right? And this is an x and 2 more. So this side right here, unfortunately I can't type on this. This would be x plus 2, and this side is x plus 2 more. And so I would have x plus 2 times x plus 2, which I could write once as x plus 2 squared. So that's a lot to look at. So these parentheses are going to become x plus 2 squared. All right. So again, that's if we took the time to factor it. You would get identical parentheses of x plus 2, and instead of writing x plus 2 times x plus 2, you get x plus 2 squared. I'm going to show you some tricks once we're done with this example. And then I need k, and k is the number that's outside of the parentheses, so these numbers here are going to give me that k. So if I have 4, positive 4, and I take away 12, that gives me a negative 8. And so now I have vertex form, and just to review what we did, I can look at this. This is my vertex. It's the opposite of this, so negative 2, and this one as is, negative 8. And then up here, I can see the y-intercept of my shape, and it's always x is 0, and then the constant, the term that does not have an x. So just putting in some review there. All right, so we're going to work through the next 4 problems. And here we go. So what I'm going to do is I just want us to get used to setting these up. So we're actually going to start here, and I'm going to do the same thing. I'm going to imagine I have those algebra tiles, and I'm going to put all the x's together. And since we're doing this process called completing the square, I'll be adding a square. And then I'll put my non-x over here. And then if I add something to keep it the same as this, I'm going to subtract it right away. So just getting this one set up. And remember, you can pause and get this written down and then press play again. So I'm going to put my x's together. I'm doing this process called completing the square. So there's the square. And then I'll put this plus 4 on the outside and minusing that square. And now I have to realize that what Mrs. Lawson showed you only was an x squared. So what I'm going to have to do here is make this an x squared. So whatever this number is what I will be factoring out, but just a 4. So that means 4 with the x squared make this, and 4 with the positive 4x makes that. And then I'm just going to copy everything down. And maybe you're asking, why don't I take a 4 from here? Because the 4 is only affecting the stuff in the parentheses. This is all independent on its own. So here, this is not x squared. There's actually an invisible -1 hanging out. So that's the number I'm going to take out, which leaves me with x squared, and then -1 with a -10x make this positive 10x. And then I'm just going to copy the rest. Again, don't forget, you can always hit pause. And now we're going to finish these problems from beginning to end, no pausing. But we're going to start with the easier one, if there is an easier one, and that'll be the one at the bottom. So remember, we took those x's, those long rectangular ones, and there would have been 4 of them here in this picture, and we always split them up. So I put 2 this way and 2 this way. And then we're going to always take this number and we're going to always square it. And so that means this squared means 2 times 2, so I put a 4. And 4 is what's going here. So I just gave you $4, but what I'm going to ask you is, did I really give you $4 or did I give you something else? And because of this 4 sitting here, that's really 4x squared. That's really 16x. What I really gave you was 16. So if I really gave you $16 over here, I'm going to have to take away those 16. So now, just writing this down so you can see where the pieces are going to come from. The way I do this, when I'm not trying to explain all the little details, is I actually start with the k. I work backwards. And so I look at what 4 take away 16 is. So that's a -12. And it's okay to swap out those addition and subtraction signs. Those are interchangeable. And then I'm going to make my parentheses squared. And our rule of thumb is we're always going to do x plus a number. I know it says minus, but we will be doing x plus. All right? And now I have to figure out what that number is. So you're going to start to see some shortcuts you could probably take. And this is a really easy bit of math to do in your head, but I don't want you to skip writing this down. Because whatever's in front of this squared is what will be in front of this squared. And then the only thing I still need is my a, and that's that 4 that I took out. So now when I look at this problem, its vertex is -2, opposite of this, and that one you won't do the opposite, so -12. There's my vertex. And then my y-intercept is this number, so when I write it as 0, and then that constant. So for this one, I'm going to go to here, and I need for you to see a -10. It's very important that you have the negative. I'm going to cut it in half. That gives me -5. And then I will always square this number. Because again, what's going to happen here, the reason why you're going to square this number is because if there's 5 here, and I realize there's negatives. So let me put one more. And then, sorry, this takes a little bit. And then I put my 5 here. Then when I'm trying to figure out how many to put in here, I shouldn't have to put all these yellow squares here. I can see there's 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So 5 times 5 is the same as 5 squared. In this case, it's -5, but same idea. All right? So -5 times -5 is 25. Whenever you square a number, it's automatically positive because a negative and negative make a positive, and a positive make a number, or make a positive. So this 25 goes in the first box, and then I look at it. Did I really give you $25? And the answer is no, because this is really -1x squared. This is really 10x, so this 25 is actually worth -25. And I know I can't give you negative numbers, but hopefully the idea is there. So from there, to make this, again, I like to start with the k. And so -1, take away -25. When you subtract a negative, that's like adding a positive. So this is really just -1 plus 25, which gives you 24. Then I'd make the parentheses squared, always x plus. And then hopefully you did not skip this step, because whatever's in front of this squared is what will be in front of this squared. And then I still need my a, and that will be the -1. So the next two we're going to do from beginning to end. So let's start here. Put my x's together. So this is the step you might be able to skip over if you're starting to see some things. So whatever I add, I'm going to take away. I need an x squared, so that means I'll be taking out that -3, and that will leave me with an x squared here, and then a -3 and a -4x will give me that. copy the rest. And now I'm going to take this number, which I need for you to see as -4. I'm going to always cut it in half. That's -2. And then I'm going to always square that number. So -2 times -2 is a +4. So 4 is going to go here. And then you ask, did I really give you 4? And I didn't. That's -3x squared. That's really -12x. So when I wrote 4, it was actually -12. So I'm going to put -12 here. And then writing this down, if you just want to see where things are going to go, again, I'm going to start with the k. And when you subtract a -1, subtracting -12, when you subtract a negative, it's like adding a positive. That's called that adding the opposite. So -1 plus 12 is actually +11, so that takes care of the plus k. I make my parentheses squared with x plus, and the number that will go in the parentheses in front of the squared is the same number that's in front of the squared. So I'll put -2. And if you want, you can always do x minus 2 instead. And then I'll bring my a back down, which is this 3, or -3. And now we have it in vertex form. So the vertex is 2, 11. And the y-intercept is 0 and -1. So last one. All right, last one, x squared plus 6x minus 10. Group those x's together. Add my square. And then subtract my square. Now this one's great because it is x squared. So I like x squared. We don't have to take anything out. So I can go straight to the 6, cut in half for 3. Then I'll square that number. And 3 squared is 3 times 3, so I get 9. And I'll put a 9 here. And then I'm just going to double check. Did I really give you $9? And I did, because there's nothing affecting this. So if I really gave you 9, now I can take the 9 away. And then just to follow this format that we're writing down, -10, take away 9 more. I have a lot of negatives. I have -19. So that's in place of the plus k. Here go the parentheses squared with the x plus. And in front of this squared is a 3, so in front of this squared is a 3. And then there isn't an a, but if you want to put an a, you can put that invisible one. I mean, there is an a, it's just invisible. And that is completing the square. So after this, there is a CUDA worksheet for you to work on if you are a remote student. Actually, I take that back. That's not what you're going to work on. So now what you're going to do is you're going to work through page 14 in your packet. So my question is, what number would have to be here to make this a perfect square? And what would have to be here to make this a perfect square? So basically, you know, they took, for this one, they took some number, they cut it in half, and then they squared it, and they ended up with 9. So you can kind of backtrack your way to see what that would be. And don't forget there's an x there. And here, this is the number, -12, that you're going to cut in half and do all that work with. So here, you're just going to be completing the square. So these examples follow what we just did on these 4. So I think the only one that might mess you up is that all of these have a constant at the end, except this one. So if you really want to put a number at the end, the number you can add that doesn't change anything is 0. So to get this one started, if I put the x's in parentheses, oops, I forgot my box, sorry. And then I need an x squared, so I'll take out that 4, and that leaves me with x squared here. And then 4 and 4x make the 16x. I'm going to make this box a little bigger. And now it's this 4 that you can start to work through. The final thing you're going to do is on number 8, you're going to get this into vertex form, so this whole thing of completing the square. But then the other thing you're going to do here is get this into factored form. And the first step of factoring is you will be pulling out that GCF of a 2. So that will leave you with this. And then this is what we're going to factor. So covering up that 2, we're going to find factors of 5 that get you to -6. And from there, I'm going to leave you. But when you're done, don't forget you're going to have your GCF of 2. And now you're going to make the parentheses that help you finish all this stuff. All right? So that's kind of putting it all together. And there will be the answers for you to check, but not necessarily worked out for you. And that's it.